Hello, everyone. It's 3 p.m., so I guess it's time to start. We gathered together today to learn something about SolaX. Be welcomed to be with us. I'm glad that you join and know something about this remarkable producer, about the remarkable product. Before we lead into SolaX, I would like to tell you about something about Menlo, organizer of this training. We are a global distributor of PV modules and PV inverters. Now we distribute over 50 megawatts of modules per month on stock in our 10 warehouses. We have all the time about 100 megawatts of modules and inverters all the times. We work right now on 37 markets around Europe, around Middle East, and around Africa. Our company is not just business. We also participate in charity, and we support energy transition. We create a plan called Energy to Power Your Future, which supports schools with PV installation. Last installation from that program was made in Moldavia, if I remember correctly. Feel free to share, to like our site in LinkedIn, in Facebook, to be aware about our activities besides business. Menlo is not only also a shop. We also gives you a support as good as we can. Of course, in matter, for example, of SolaX, our today presenter Mirosław Mikowski is much better specialist. But if you cannot reach them, if you figuring what solution will be best for your client needs, here we are to support you, to give you an answer, to give you a clue where to look solution. This is how you can contact with us through our hotline or through our support email. So that's all about Menlo, which I would like to mention in the beginning. And we reach SolaX and Mirek, which is employee of SolaX, and he will share with you with his knowledge about SolaX, about their solution, especially with hybrid solution. Mirek, floor is yours.
Okay, thank you so much. Welcome to the SolaX Power webinar and SolaX Power on the Menlo webinar. As Mikołaj said already, my name is Mirosław Mikowski, and I work for SolaX in Europe. And well, I try to tell you how we do the hybrid system in SolaX. Today, mainly we will focus on the residential energy storage system. And in first part, we will have a look on product portfolio. And we will have a look on the product portfolio, key features, and the system overview. And also later we will go to system examples, cable connection, setting and commissioning, and some installation tips at the very end. I hope I will manage to do everything within 1.5 hours. So sit down, relax, and let me talk. So now, a milestone for SolaX that was founded in 2012. A year later, as the first Asian producer, we released energy storage inverter, hybrid inverter. So between the Asian producers, we are the oldest when it's going about doing hybrid inverters. Well, now we are doing the 4th generation, and and another generations, let's say something like 5, but these are not replacing the 4th generation, are already just about to be released. So we know for years already how to do hybrid solutions. And as you can see, not only hybrid solutions are for us. Well, here are hybrid solution, but we also produce regular grid inverters that cover the power from 0.6 kilowatts up to 150 kilowatts. So you can find in our portfolio also regular grid inverters. But today we will stick with the hybrid solution and with the energy storage batteries. So let's move on to another slide. Right. So our ESS product portfolio contains, as you can see, first of all, it has to be a hybrid inverter. So on the hardware way, on the hardware side, we need to have an inverter. We need to have some kind of a batteries in a proper amount, and then last but not least, the metering device, which is usually meter or a current transformer CT. These are the basics. Without any of those, there is no hybrid installations. All the rest can be added as an accessory, as supplementary thing. But basics are the metering device, battery with BMS unit, and hybrid inverter. Between other hardware, you can see also things like BMS parallel box and the data hub and pocket and all those other accessories. Well, I will tell you exactly what the BMS parallel box is for later on. The data hub and the pocket Wi-Fi are mainly for communicate with our SolaX cloud, with our software for monitoring. But data hub has much more can do much more things than just a pocket. Pocket is just for sending data both ways, and data hub is for gathering many inverters into one place and be a common monitoring device for many inverters, and be a common energy management device for all those inverters or EV chargers that are connected into the data hub. So just one small box can do many really fantastic things when it's connected with different kinds of different types of inverters. It can be grid inverters, it can be also hybrid inverters, and also EV chargers. And the accessories, they are not necessary to be, but they are making that the hybrid looks better, works better, it does a better job for typical situations. Sorry, I have to close. Okay, does a better job for many situations that when those typical solutions are not enough. So we can enhance, we can build a larger energy storage magazines. We can connect many inverters into one system, and we can support the whole full load, so the whole house in the emergency power supply. Or we can even cooperate with the heat pumps to make them be another energy storage system for the PV access for the PV energy. So all those accessories are making that SolaX can do more and more. So we have basics, and we have accessories that can make those basics work better and be matched to the different needs of our customers. So there's plenty of talking about one slide only, and we still have many of those. So let's move on. Right, so now quick look at the inverters and the power range. Well, first, the most popular X3 hybrid G4. So three-phase inverter, and from 5 to 15K the AC output power. And the single phase in SolaX is always X1 at the beginning. So when you see X3 at the beginning, it's clear that this is three-phase inverter. And when it's X1, obviously it's a single phase inverter. Single phase, very popular in many countries, from 3K up to 7.5K. We also have FIT versions, which are not working directly with PV installation. They are just managing the AC power that has been detected on a house and it has been produced by something else. This something else is usually some old PV installation or wind generator, or there is even a cheap tariff from the grid. You know, if you still feel that this is a really good deal for you to charge when it's cheap and discharge when it's expensive tariff, then yeah, FIT is also a good idea. And what can we do with those inverters? Well, as you can see, there is no oversizing for FIT because, as I said, there is no PV installations connected directly into the FIT inverter. But the hybrids can be oversized even up to 200%, and the number of MPPT strings you can see two. The smallest one, they have only two single input MPPTs, and the biggest one have also two MPPTs, but the first MPPT has a double input. Current max input current is 16 amps for our hybrid inverters. Right, jump into another one. Now we have batteries. So as I said, no hybrid system without inverter, without batteries, and without metering device. So inverter is already checked. Now the batteries. Currently, we have two types of batteries on the market. Another one is just banging the doors. It will be very soon. But those first two, and they are for years already on the market, and they are really proved that they are really good batteries, are HV30, called in short T30, and HV58, called T58. So these two batteries are not the same. They cannot be connected together. They are different batteries, but they are created for do a little bit different things. Apart of that, of course, there's energy storage devices. But when you're going for a bigger system, when the number of kilowatt hours really counts, then you obviously going for the T58, which every single battery of that T58 has 5.8 kilowatt hours, and the T30 has only 3.0, but T30 has this nice slim look and has the battery heating inside installed. So it's smaller, but can do more, can do different things, can be installed outside, even when there is a winter time with minus degrees outside. It's fine for those batteries. It's not fine absolutely for T58. They always have to be hidden in the inside of the building, where the temperature never goes down below zero. And what they're sharing the technology of the battery cells. They're both LFP cells, the most reliable and good on price, and widely produced type of the battery cells. So that's why they have 10 years of warranty, or 6,000 cycles of the lifetime that we are declaring. And so what we do when you want to do a bigger system, because as you can see here, the capacity is from 3 to 12 for those smaller batteries, 30, and that's it. For now, you cannot go over that when you're connecting only one inverter the batteries when you're using all those T30 batteries. But when you do use those T58, then you can reach even over 46 kilowatt hours combined with one inverter only. So, but for that, you will have to use at some stage BMS parallel box, but we will have a nice slide later about this. I just wanted to just to introduce that right now. And the smallest battery that I have listed in here is it's going to be 2.5 kilowatt hours. And with using those batteries, we can reach up to 32.5 kilowatt hours of the ESS. And yeah, that's it. Well, they are high voltage, and they are also quite high with the amperage. So the power that you can have from the batteries is really nice, because the smallest one, the T30, can do 2.5 kilowatts of the constant power, and the biggest is reaching over 3 kilowatts of the constant power. So this is really nice when we're talking only about one single battery. But then you can combine up to, let's say, 4 batteries. So you're just multiplying this, and you're reaching nearly 10 kilowatts of the constant power from the smallest batteries, and over 12 when you using the T58. Right. Let's go to the next slide. Next slide is about the energy management. So for me personally, they are all very, very important, because there should be no hybrid system without monitoring. And as you can see here on this slide, there are monitoring devices on the left and in the center, and all the hybrid systems, they should have monitoring. That's very, very easy for everybody, for installers, for end users, and also for us on the service, to monitor, to check what's going on the system, and help and be really quick and better with helping of our customers. But the most important thing is also here the meters, the metering devices. It can be meter, or it can be also a current transformer. These are eyes and ears for the hybrid system. So without them, there is no hybrid. Hybrid doesn't know what to do, doesn't see where the house ends, doesn't know what concerns him, what he should supply from the batteries or not, because it has to be some kind of a border between grid and a house, and that border, it's called measuring device, meter or CT, and has to be installed exactly at the border between the grid and the house. Right. Let's move along. Accessories, matebox, EPS parallel box, EPS box, and adapter box. Matebox is just a nice part that is just creating this nice smooth column called all-in-one in SolaX. So it's just covering the space between batteries and BMS and the inverter, and it contains inside all the necessary switches and ports, that so you can do your work, your connection of the SolaX devices together, and bring, of course, the AC power from the house and the PV power from the PV installations. Everything is easy, and at the end it looks really nice because it's hidden. There is no wiring everywhere. It's just nicely hidden and inside the matebox. Matebox is in the 2 versions. The basic is the more popular one. It just does that work, for good looking and making the installation much easier. And the advanced one has some special devices inside, which are preparing matebox for and the whole hybrid system for supplying of the whole house with this with the emergency power. And this is so if you use a matebox advanced, you must know that this is first you're going to be using you caring about the emergency power supply, and you will connect the whole house into it, because it's pre-wired already that way. So there is no really, without dismantling this, there's no really to do other way, because there is also a meter installed in there. So first, as I said before, the meter has to be on the border between the house and the grid. So if that border between the house and the grid is in that matebox, so you have to bring the power to all the house first to the matebox, and then you can go back. And if the whole power comes into the matebox and just passing the device, the switching device, then the whole house will have also emergency power supply. The big EPS parallel box right beside, it's just a big switching external ATS switching device for many inverters. So if you use 5, 6, or 10 inverters connected together into parallel layout, it's going to be later about this also, then you have to use this one. Of course, if you will use EPS power, emergency power supply, if you care about this, then you have to use this. If not, if there's only many hybrids and many batteries, no emergency power, you're going to have to buy it. It's okay. But when you need to have emergency power connected to your house, yes, for multiple inverters, hybrid inverters connected into parallel system, you have to get this EPS parallel box. EPS box is just EPS box for a single inverter, or maybe 2 maximum. So it's not that big as the EPS parallel box, but does the same, generally speaking, does the same for a single inverter if you need to cover the whole house, all the load in the house with emergency power supply. And the adapter box, so all those three, matebox, EPS parallel box, and EPS box, matebox advanced, speaking to be more specific, matebox advanced and EPS parallel box and EPS box, they can do the same. They are external ATS switches. All our inverters, hybrid G4 inverters, they have built-in internal EPS switch, which is really great, and it's perfect for situations when you EPS power will be good only for will be used only for part of the house, for the critical loads like lights, some other things which are really critical, and all the rest will be all the rest of the load in the house doesn't have to have no need to have the EPS power. So then you can use the internally built-in switch. But if you're going for the full house, then you have to use one of those, matebox advanced or EPS box. And when you're going for the full house with many inverters, then you have to use EPS parallel box. Right, adapter box. This little box is to connect our hybrid G4 inverters and also other ones with the heat pump. And using that one, you can turn the heat pump, which has to be SG ready, turn the heat pump into the a high level work to use extra PV energy that will normally go to the grid, to use that PV energy to boil the water, just to accumulate this energy as a hot water. So that's making that your hybrid doesn't have only one energy storage in batteries. It has also another energy storage as a hot water in a boiler. Okay, I think I should speed up. Right, so key features for our ESS, for SolaX energy storage systems. When we're using generation 4, we can talk hybrids, we can talk about 200% up to 200% oversizing. We can talk about a really nicely working unbalanced output for the three phases system. So the AC power can be really match the actual and real need on your phases in your house, not just equally to each phase the same, just exactly as it's as the need is. And another feature is the fast switchover. That is about this internally built EPS switch, which is really fast. But it will be another slide about this. Wide working temperature, I already mentioned this. It is about that the batteries, T30 batteries, can work outside on a freezing condition also. GMPPT, that means a shadow fix. But there will be a slide about this also. Cloud management, using SolaX Cloud and having inverter connected into the monitoring, SolaX Cloud monitoring, you can access that inverter. You can manage, you can change settings, you can change your work modes, you can activate your EV charger, stop your EV charger, you can activate your heat pump into the other type of work. You can do many things just because you have cloud management. And of course, all the settings, nearly all the settings can be done through the remote settings. So this is really handy and really useful tool that SolaX has created and provided to all of us, because I'm just really using this every day and it's really fantastic. The EV charger, yes, we do produce a EV charger. I will have a few words about them later. Generator compatible, we will also have a few words later. It's just, there are places on the world when the grid is gone for many times, for long, and sometimes the batteries are not enough. PV is gone because it's night battery, there is not enough batteries, and then, well, then the generator is just necessary to be an emergency power for an emergency power system. For example, in my country, there are winters as we have, short days, a lot of snow sometimes, so you cannot count on really on the PV to be working and fully efficient for the whole year. So sometimes that generator makes that the off-grid system is really possible in countries like Poland, where I live. Right, so oversizing, what's the story with the oversizing? The story is that, as you probably know, it's good to oversize because, of course, you will have in the middle of the day, it will be cut, but at the morning and at the afternoons, you will have much power. But with our inverters, there will be no cutting power, because as long as the battery has the space to be charged, this oversized energy will be loaded straight into the battery. So that's a good feature. But as always say, as long as the battery is not full, because when it's full, then it's full. You cannot charge more than 100%. But it's still, well, maybe not totally 200 everywhere, but you can go over 100% and feel safe and know that this energy will not be wasted. Right. Three-phase unbalanced output. That is really something good, and it is improving the efficiency of this system. So if you enable this function, each phase in your house will be treated separately by inverter and supplied separately by correct amount of the power. Of course, there are limits, like there are limits for anything on this world. Maybe there is no power. Let's say there are limits for everything in this world. So the limits are up to 5 kilowatts per phase, or up to 50% of the inverter output power. So if you have 5K inverter, he will have only 2.5 kilowatts per maximum per phase, because that's his 50%. But 10K inverter will match to both of those limits. So he will have 5K on the phase and also 50%, that is 5K on the phase. And it is really working. I saw this many times. It's really doing within those limits the work. Right, GMPPT, that is shadow fix, a scanning. So if you have situations like at some stages of the year, the sun is that low, so the tree that doesn't bother on the summertime, it does bother on the other times of the year. So it does the shadow for few panels. So GM shadow fix is just improving the work of the MPPT, and it's just like squeezing the string to take more power from those panels, PV panels, even they are a little bit under shade. So that's what this function is doing for some situations like chimneys and trees and I don't know, maybe leaves or some kind of a dirt laying on the PV panels. So that kind of situations it is for. Fast switchover. It is less than 10 milliseconds of switchover time. And this fast switchover is when we're using this internal built inside of the G4 inverters, the EPS switch. It is created to supply the part of the house with the emergency power, but those loads, they must have power all the time. Doesn't matter where it's from. Is it from grid or from PV or from battery or from emergency power supply? So when the grid is separated, on those loads, this, critical loads, EPS loads, the voltage, the power should be all the time. So that's the idea of this EPS switch. And but of course it has a limitation of little bit over 30 amps per phase maximum. So if the flow from the grid to those EPS loads, to those critical loads on the normal operation time can be bigger than this, then sorry, we have to go for external switch, and that's it. Generally, like counting, it is double the power of the inverter, the output power of the inverter, or not more than 20K. That is the limit for those ports in the EPS switch that's built inside. If you need to use the external ATS, then you have to look around for EPS box, EPS parallel box, and matebox advanced, as I said before. Right, a frozen environment. So only T30 batteries, only them have, like for now, only them. We're gonna have another type of batteries on the market later this year or next year. They also will have this battery heating, but like for now, you can order only those batteries and with the battery heating, and only, of course, only those batteries can be installed outside on the freezing temperature, and they will work properly. They have just heating mats in there, and they will, if the battery cell, the coldest battery cell will be at some certain level, the battery heating will be on, and it will heat up to over 10 degrees of Celsius up, and then it will be off. And it's going to be used only when it's necessary. is not used all the time. It's automatically, well, not automatically. You have to activate that function and set the whole day long to work for that function, and then it will be automatically. When it's necessary, it's going to be used. But please remember, only those, no T58 batteries outside when you live in a place where the temperatures can go down below 0. Okay. Cloud management, as I said, we can do many things through cloud management. We can do remote setup and upgrading of the firmware, and while we are introducing very shortly a new pocket Wi-Fi that will have a 10 seconds refresh rate, so the cloud will be quicker and again better than it was. There's, as I said, there should be no hybrid system, or generally no inverter without cloud monitoring. This is really important to have all those things connected to inverters, so we can all have access and do our work with supporting our customers. EV charger. Actually, right now we're producing 3 EV chargers. So it's one single phase and two on the 3-phase, 11 and 12, 22 K of the output. And what's interesting about SolaX EV chargers, of course, they charge cars, right? Many EV chargers are charging cars, but SolaX is always trying to use as much of wind energy as it is possible. We even prepared a special work mode, which is called Green Mode 6A, that will use only PV energy. So only on the excess PV energy the car will be charged. Of course, there are always other work modes that they are using more or less the grid power. But if you're really intending to stay green and use only PV created energy, yes, you can use SolaX Green Mode 6A, and that's it. It will charge your car only with the energy straight from sun. No, maybe not straight. It has to go through PV panels and hybrid inverters, but as straight as it is possible. Okay, generator compatible. Most diesel, I said not only diesel, combustion generators, they just have to provide acceptable of the AC power. There has to be with the acceptable range of that inverter can take. And well, inverter can work with the generator on a different types, from really manual without any ATS, just starting manual generator when it's necessary, so the generator appears as a spare grid and that's it. Through the ATS, so the generator is running all the time, even without supplying, but it's running all the time. And when the SolaX inverter has not enough of the power in the batteries, then the generator is taking over the supplying of power in the house. And then it can be also automatically, so the generator will be activated to work by inverter, and deactivated when the inverter will see that the battery is already full, and the generator can stop and we can have a power in quiet again. So all that is possible. There are different types of settings, and well, if you need to live with generator, you can look closer to that solution. Of course, you can find more about this in our knowledge base that's on the kb.solaxpower.com. Just browse there a generator and you will find whatever you need. And this is only for, of course, for X3 Hybrid G4, and this X3 Hybrid G4 must be updated to the latest support, to the latest software, to have these functions to work with the generator. Okay, where are we? 18 of 50. Nice. Again, I must say that I will speed up. We will see if I speed up. System overview, a standard ESS solution. So standard, it looks like this: grid, meter, SolaX meter or SolaX CT, and there are general loads, and there is a hybrid inverter which has batteries connected and has also these backup loads, critical loads connected directly to inverter, because that inverter will use his internal EPS switch, and of course the PV panels. They have to be, and you can see over the inverter that it is connected to the monitoring, of course. And so on that is the most commonly used scenario. That's 80% of all those installations that we are selling, or those sets that we are selling, they just look like this. So in here you can also, of course, set zero export control, because all the power from the house created on the house is dependent on our inverter, and that inverter has the metering device, the meter or CT. So that's why it can keep the zero export control, because it's the only source of the power on the house. Right. Another slide is about what's happened when there is another source of the power on the house. Of course, here we have marked this as a X3 feet, but believe me, it can be hybrid with his own PV installation. There can be 2, 3, 4 PV installations in the house with different inverters. Doesn't matter, as long as our SolaX meter 1 will detect any extra power trying to go to the grid. This power will be used by our feed or hybrid inverter and redirected into the battery. And of course, the inverter feed or hybrid inverter will supply the house with the battery power when there is no PV power anymore, or is not enough of that PV power. So that's how it works. It works really automatically. Any third-part inverter can be used. We're not communicating with him anyhow. We can measure his energy flows with another SolaX meter. That's possible. Not necessary, but yeah, that's possible. It has to be a meter, and it has to be a meter with address 2. But it's not really necessary. Just our meter 1 will see that power, and we will use that power to charge the battery. And in this solution, the zero export control is not possible, because we're not able to force the other brand inverter to stop production. So it will have to be done on the according to the solutions that the other brand is providing, if the zero export is necessary. Right. So this is about the parallel. I mentioned this when I was talking about the EPS parallel box. So imagine yourself that, well, you feel that one single inverter, 15K is not enough. Our biggest 50K is not enough. You have more, more needs. So you can put another one and multiply them up to 10 units. connected together into one system. Of course, every single every single inverter should have his own batteries, and they should be on the same number and type of the batteries to make it run smoothly. You know, of course, I heard about many situations that there was not equal number of batteries. Yeah, of course, you can manage and you can, you know, have this for half a year or year, but then maybe something will start to happen. So we are always saying, you know, basic rules are like this. Inverter, if you're using many inverters, they should be as a copy and paste, you know, just the same under every single inverter, and then we know that they see each other as equal partners into that work. And if there is a EPS scenario for that house, so if there's any backup loads, if there is a need for things like this, then the EPS parallel box should be used. When we have like over 3 hybrid inverters in the parallel system, then yeah, EPS parallel box should be used. And there are 2 types of the EPS parallel boxes: smaller, up to 60K, or up to 6 units. So whatever comes first, 60K of the energy flowing through, or the number of the units, and the bigger one is up to 150K and up to 10 units. So you can choose between 2 of those EPS parallel boxes. Right, system overview. Again, so how the general hybrid solution can look like. Well, you can. It's not just you know, one choice. You have to buy 10 kilowatt hours battery, 10 kilowatts inverter, and that's all you can choose. No, there is a really wide range of that what you can choose with SolaX, with a single inverter starting from 3 kilowatt hours of battery when there is a single phase inverter, and you can go with single inverter even up to over 46 kilowatt hours of the batteries. So the range is wide, and depends what you need, what your customer needs to have in the house, how many kilowatt hours a day roughly he's using, and that's it. That's the basic thing that you should know. Of course, you can always use the minimum size, you know, and there is you don't have to really match to all those kilowatt hours that he's using daily. But if there is, we're not talking about the minimum system, then you can go up to 46 kilowatt hours of batteries with one inverter only. Here we have a situation when there is of course critical loads, backup loads, and normal loads. So we're using the internally built EPS switch. So that's how it looks. There's no matebox over here. There's just a regular, the simplest layout of the system. So battery in minimum amount, and the inverter, and the measuring device. Now here you can see the CT that is installed between main breaker and the inverter breaker. Okay. So you can see with those, we can use both types of batteries with inverter. There is not that just T30 can be used with generation 4. No, the older batteries also can be used. These are the same technology of the battery cells, and they are really compatible with software with all the inverters of the generation 4. Right, when we go in for the all-in-one solution, so it has to look really nice, and it has to have this matebox, you know, inside, so it's easier, quicker, and looks better. Then that's how it looks. And of course, as I said, matebox comes with in two types: basic and the advanced. Advanced has this metering device and the DPDT switch, so this external switch. So it is used for the whole house backup scenario, and for the normal scenario, like just part of the house, then you can use basic matebox, and it will do the job also nicely. So it will cover all the wirings and close the space between inverter and batteries into really nice looking column. You're just saving a lot of time, you know, when you get used to installing those mateboxes. You will see how easy it is, you know, just clicking into correct ports. Everything is nicely prepared, and a lot of work is done already by SolaX in the factory. So, right, so let's now move to, hey, we're at the half of the presentation, and 50 minutes gone. Nice. Connecting. So the first, let's see how we're connecting the PV. The PV goes to the MPPT strings. Always, please, what's important, always use those plugs that SolaX is providing. They are coming together with the inverter. Don't use other types of plugs. When you're connecting plugs, they should be from the same factory. I work on a service long enough so I can tell you it is not a good idea to mix different types of plugs. Though they look quite similar, well, sometimes it ends badly. So always use proper SolaX provided PV plugs and just print them correctly, click them inside to the plug, those terminals, and it will be very good, because SolaX is providing really the most solid PV plugs you've been ever used. You know, these are really nice and solid ones. Jump to another one. AC side. When we have emergency EPS scenario, then you have to bring two wires into your AC side of inverter. So not only grid coming in, but also EPS off grid coming out and going back to the house switchboard, where is supplying the power for those circuits, for that part of the house that has to have this emergency power supplied. After installing, there's a flat screwdriver. Please use a proper one, because if you use not too small or already worn, well, it's not so easy to put all those connectors tightly, really, and make sure that all those wires are really firmly set on the ports. After that, after connecting wires, just have to install the waterproof cover and the waterproof fastening heads. So that's the AC side. Now the battery. With the BMS unit, so with battery master of T58, or with the BMS unit for T30, there are wires attached to connect that BMS with the inverter. There are 3 wires. 2 are electrical wires, so for plus and the minus, battery plus and battery minus, and they are done on one side, and the other side you must use those plugs, battery plugs, that they are provided with the inverter, because, as I said before, they has to be from the same type and same factory. So inverter has already installed battery plus and minus ports, and also has provided plugs for those ports in the inverter, in the accessory body of the inverter. So use them, crimp them on the other end of the wire that is coming with the BMS, and then they will match perfectly to each other. And there is also communication, very important thing. Communication goes from the BMS into the BMS port of the inverter, and it has to be really firmly and correctly clicked into the ports because our batteries they do communicate to each other, with BMS and with inverter, and it is really important to have everything firmly, correctly on the place. Then you will have you'll be sure that there will be no problems with the communication between devices. Right. I'm slowly losing my voice, so that means that we are closer to the end. Another battery connection slide. The T58 solution, where the BMS unit is built into the master battery. So you need to have an inverter plus T58 master as a first one, and then you have another battery as a slave. So the maximum size of those, maximum number of those batteries in that kind of a simple layout. So when we're using T58 master as a first one, is up to 4 batteries for 3-phase inverter and up to 3 batteries for single-phase inverter. Of course, when we use BMS parallel box, there will be a different story. That's going to be on the next slide. And right now, let's focus on that we have something that's called deep switch. This is on your right side at the bottom, and that deep switch is installed on the top of the T58 master. When you remove the cover from the T58 master, you will find there an MCB, so the breaker, battery breaker, battery power button, and there is also that deep switch. And on that deep switch, that is really important, you have to set number of slave batteries, because let's say master knows that he is, but he doesn't know how many slaves he has to expect next to him. So you have to set him on that deep switch. Hey, there is 1 slave, so you set him 1. There are 2 slaves, all right, so you set him 2, and there are 3, then of course you set him 4. You set him 3. Sorry, and so that's important. Before you turn battery on, you have to set a proper number of slaves that has been used in the system that you just installed. That is for installers. And for those who are selling, so for salesperson, you must know that when you're selling 3-phase inverter, you have to sell minimum 2 batteries with him. 1 battery won't do. 1 battery is good for single phase. For 3-phase, it has to be minimum 2 batteries and maximum 4. So that's for those who are selling and just like preparing the offer for customers or doing some kind of projects. You have to remember this minimum and maximum number of batteries. Good. Okay, now when we feel that 4 batteries might not be enough, then it is better, even if you don't buy more than 4 batteries right now, it is better to use the BMS parallel box instead of T58 master and slave, and only slave with this. So BMS plus slaves, and then you can, when you have BMS parallel box, you can use only 1 group or 2 groups of batteries. That's why we are doubling the size of the energy storage system, because we're using 2 groups instead of 1. And again, we have a deep switch here. It is popping up here because when you're using only 1 group, you're just leaving as it came from the factory. It's set on 0. That means there is no other group, just 1. And if you set this dip switch on 1, that means there's another group of battery start looking for them. So that's the thing that you have to do on the dip switch. Just show to the BMS Firebox how many groups of inverters is on that system. And then, so first batteries are going into the BMS parallel box, and then BMS Firebox connect that batteries to the inverter with regular three wires, so battery plus, battery minus, and the communication wire. That's how we can make this battery storage system bigger when you're using our inverters and our batteries. Right. So as mentioned before, the commissioning and preparing battery to be turned on for T58 battery, you have to look at the dip switch first before you turn the breaker on and push the power button. Just check if the dip switch is on the correct position. And for the T30 batteries, there is no dip switch, so just breaker on. Of course, first connect everything properly on wires, and then breaker on, power button for 1 to 2 seconds to start the system, and the system will start automatically. Of course, when you're connecting anything from the battery side to the inverter should be switched off. Don't risk that you will have electric shock because you try to connect the battery into the working inverter, or turn a battery that is turned on into the working inverter. That is not a good idea, absolutely. Right, so overview for T30 solution. Those before T58, they are mostly hanging on the wall. Each battery has its own, so maybe I will show you back those batteries. They usually installed mounted on the wall, but they can also, of course, be standing on the floor. And those T30 batteries that I'm going to be presenting for you now, they are standing on the floor, on the base, and then those batteries, they go up like the bricks, one on one, on another one, the BMS on the top, and then between the BMS and the battery, there's a bracket to fix this to the wall to secure the whole column and make that it will be safe for use, and it won't fall off the wall if somebody will try to push this or pull this from the wall. Number of batteries, as you can see, for a single phase is from 1 to 4, and from the 3 phase is from 2 to 4 batteries, and that is the maximum that you can use. The only one, but when you using the single column installation, so you just installing over 2, like 3 or 4 batteries one on one, you have to purchase separately the power cable that is for 1.2 or 1.8 meter long. Of course, when you buy for yourself like as a spare cable 1.8, it will cover all the situations. So I guess it will be more popular that 1.8. Of course, when you're using 4 batteries one on one, this battery system is a little bit high already, because the base and the BMS and 4 batteries, we are already like 2.3 meter high or 2.2 meter high, so it's already high. So there will be no way to put the matebox and inverter on the top, because you will have already 3 meters high the place where the inverter is. So then inverter will have to be just aside of the the system, of the battery system that you can see here. But we don't have to go that high. We can use two-column layout, and as you can see here, we can put 3 batteries or 4 batteries in 2 columns. And for that kind of scenario, we must buy 2 extra things: accessory pack, which contains base number 2 and waterproof cover for the for the second column, and of course cable, power cable to connect bare minus from the BMS with bare minus in the last battery in the row. So that's why you need to purchase 2 or add to your order 2 more things, like power cable and accessory pack when you're going for the double column. Okay. Connection of the CT sorry, and meter. My tip for everybody: when you're doing 3-phase system, you don't have to be worried when you're doing single phase, but when you're doing 3-phase system, while installing meter CT, first always check and arrange phases according to the phase rotation, and then keep the same phase order on the meter CT and on the inverter grid ports. That's really important. That's for installers, of course. For electricians, to keep that before you install, just check those 2 things, and once that's done, there will be no problems with readings from CT or from meter. And there are some notes, rules for the CT to not be installed, of course, on the N wire or 2 wires together, and or non-insulated wires. And of course, the arrows should be pointing correct direction. For the standalone CT, is the arrow should go to the grid. So sometimes it might happen that they will unclip themselves. So it is always a good idea to secure them with some kind of a tape or something like this. And the distance between the CT and the inverter, the communication line distance, after a few years of experience of using those CT, it should not be bigger or much bigger than 10 meters. I would say 15 meters is still okay, but so 1.5, but 40 or 60 or 100 meter, no, this accuracy really is not good then. So it is always better to use on that places, just use meter instead of the CT. Meter can go up to 100 meter of the communication line, and there will be no problem with sending that communication on that distance. Meter and CT connection. Very important is to match correct pins when you're crimping the RJ45 plug. You have to connect with correct pins, because like meter is using only pin 4 and 5, and the rest of the pins is used accordingly by CTs. There are six other pins in that port are used by CT. That's for the 3-phase system. Of course, with single phase is like CTR, so it's only 1 and 8. And the length of the wire, the CT is coming just with a short piece of wire and with the connector. The connector, to make extension, it looks like this. This is like that's supplied in the together with with inverter, and so you can always extend this communication line from CT into inverter. Please always check with the LAN pair testing instrument if your communication line that you're using is really crimped correctly and all those pairs are on the place as they should be. Right, so heater and CT is done. Now the Wi-Fi connection. Pocket Wi-Fi, actually version 3.0 right now, the black cover, they're not compatible with the previous one, different communications, so don't try to mix them. The older generation inverters that using Pocket Wi-Fi 2.0 cannot be cannot have monitoring when you use Pocket 3.0, and opposite when you use old white Pocket 2.0 trying to connect with new inverters with new type of a socket prepared for Pocket 3.0, it won't work. No matter how long you will spend trying to connect them, it just won't work. It's a different communication, different chip inside, and different communication type. Sorry, it just won't work. We had to start producing new Pocket Wi-Fi 3.0 because there are cheap suppliers stopped to produce those who have been used in the 2.0 version. So that's the reason. Okay, as you can see, they are working in 2.5 G network and IP65. They are clicking nicely on the place, so the installation of them is much easier than it was before, because it's just one click and that's it. You can choose between Wi-Fi regular or Wi-Fi with external antenna, and there are also two different types of antenna to be used. So even if it's far from a home router, when you use this external antenna, it is much easier to connect the monitoring when you have those Pocket Plus with external antenna. So once everything is prepared, then you just clicking this on the appropriate port, and then you can go to and connect this with cloud. First with inverter, so with home router, and it's very easy right now because you don't have to use any special secret pages and in your browser. You're just using on your account, going on your user account, going into account section and to the Wi-Fi connection, and then just follow the steps that this function is bringing you through. And there is also the same type of Wi-Fi connection on your installer account. So once you log on that installer account on your smartphone, you will have also that functionality. It's really nice, and connecting to inverter using this Wi-Fi connection is really nice and quick. So we are at the 40th slide. Okay, inverter main settings. The main settings before you commission the inverter, because before you allow him to work, there are some main settings that they have to be done. So it's like mostly it is the safety code settings. Then you can choose the work mode if you want to choose different than the standard. And of course, if you go, you have to check the meter or CT settings, because if you have installed the meter, then you have to turn the meter, work with meter in the inverter menu. And you can also set the export control because it's very well, it's necessary in many countries, so that's why it's important to know how to do that correctly. Right, safety code. Safety code on the LCD screen, just as you can see, 4 buttons over here: back, up, down, and enter. Press enter, go to menu, to the settings, enter password that for installer by default is 2014-2014, and press enter. First, on the advanced settings from the top is safety code, and so just enter into that safety code, and then you can see what's now. If it's correct, then you do nothing. If it's not correct, then you just have to edit this, press enter to activate the selection. Then those 2 arrows on the side will appear, and then you can, by using up and down case, choose appropriate safety code, and then confirm with enter again. My suggestion is when you go back, then go in again and see if on the main page that what you have just choose, it's set, and so then you'll be sure that it had been set, so all the settings, all the grid standard settings are on the place. Cool. Now work mode selection. You can change your work mode if you don't like to work with self-use. That is like 90 or 95% of users are using the self-use work mode. Then you can go and change that work mode on something else. It can be feeding priority, backup mode, or manual. Manual is used when you need to force charging or discharging of batteries by some reason. It can be well, different. If you feel that you have to really quickly charge or discharge batteries because of some reason, then mostly charge, then you can activate manual and force charge, and it will charge battery no matter from where. It will charge batteries from grid easily. So I have a slides about. So that's how this selection of the work mode on the LCD looks like. You just go into the menu, then you go on the work mode, activate, and then changing up and down work mode on another one, and of course activating, confirming with enter. So maybe now what is the logic of work of the work modes? This most commonly used and set as default is the self-use. The logic is like this: building load first, so the PV energy first go on the building, then the surplus energy is used to charge batteries, and then if the batteries are full and the building has no needs, and then we have surplus, then this surplus will be exported to the grid, of course, if export is allowed. And logic of using batteries in that work mode is the charging with any surplus PV energy, surplus over home loads. Doesn't matter the hour. You cannot limit, like for now, you cannot limit the hours of charging from the surplus PV energy. It will charge anytime it will be detected that there is any extra energy coming from the PV. And charging from grid also in cheap tariff, but for this you have to enable this function, set into how many, what is the level of charge, so what's the state of charge that you want to reach when charging from grid, and then you have to set exactly periods. So from which hour to which hour you are declaring that there are cheap tariff hours, and you are allowing to charge using that grid energy. And discharging from batteries to loads when there is no longer enough of the PV energy. And of course, unless discharging is not prohibited at this time, because you can also prohibit time of discharging at some hours. You just set it, you can set discharging hours as you want. Not recommended by me personally. I like when this system works automatically. But if you want it, yes, is there. You can limit that. It's called allowed discharge period start time and allowed discharge end time. And once whatever you set in here, it will limit it will discharge battery only from 2. And that was right over. If you see on the right hand side, on my right hand side, because of course you don't see my cursor. Okay, that's hours for charging from grid. So if you don't want to charge from grid, don't touch those hours. But if you do want to charge from grid, set exactly hours from 2 for those cheap tariff hours. And then inverter will know that in those hours can charge from grid. Of course, if you enable this charge from grid, you can see over that there is a charge from grid disable. If you enable here in self-use, then it will start to use energy from grid to charge batteries in those hours that you will set as a forced charge period start time and forced charge period end time. Okay, and yeah, those hours of charging from grid will automatically limit discharging, because that will be not logical. You know, when you have a cheap hours, you don't need to discharge in cheap hours from battery. Just keep that energy in battery for those expensive hours, right? So don't be surprised that if you set here couple hours of charging from grid, in that couple hours there will be no discharging from batteries. It will be only charging. Feed-in priority is a work mode that is prepared for countries where you have some kind of agreement with the grid provider that each day you have to export some certain amount of the kilowatt hours into grid. So that's why logic is a little bit changed. First, of course, building needs, and then this surplus, this extra energy over that building is going to the grid according to the amount of power that is set, that needs to be exported to the grid. And then after that's done, and we still have a surplus energy, then you can charge batteries. And batteries are working on the same logic as in the self-use. So they are charged from the extra energy, and they are discharging when there is not enough energy from PV installation. Honestly, I don't know in which countries exactly that is used, but absolutely not in place where I live. Another work mode is the backup mode, which is it's kind of a different self-use. It's prepared for the places where blackouts happen often, and we have to be ready, at least a little bit ready for any blackout that can come, you know, any hour. So it's already the minimum level of the battery charge is higher than it is in self-use. In self-use, it's 10%, and in backup mode already is 30%. Of course, it can be edited and change it into something higher over that 30. And so all the rest of the logic is the same. So building first, second batteries, and at the very end is grid if export is allowed, and batteries using energy from batteries, same. Charging when there is extra energy, charging from grid when there are hours set, and discharging to loads when there is not enough of the PV energy. And so the backup mode is just preparing the system for work in the EPS in the EPS mode. Okay. we are very close to the end, ladies and gentlemen. So I was talking so much about those about the charging from grid, right? But I understand that in many places, for example, in Italy, as I heard from one of my colleagues from the that work for SolaX in Italy, they have sometimes they have a cheap, not even cheap, a free hours, 2 or 3 hours overnight, when they don't pay anything for the kilowatt hours that they take from the grid. So of course those hours are really nice to charge the battery to full and then use that free charge charge energy for the rest of the day and the rest of the night. So charging from grid for those places is really substantial and important. So here you can see how to set in different work modes that charging from grid, where to send to achieve that what you can that you want to achieve. As I said before, charge periods, forced charge period times are just pointing exactly for the inverter in which hours he can start take energy from grid and load that energy into the batteries. And of course, you can set into to what percent of the capacity charge the battery. So if you set 85, it will charge to around 85 and then it will stop. But if at the 22 battery will be already to 85, then it won't charge because it's already done, right? So it's not that it will charge anyway, no matter the battery state of charge. If its battery is charged or charged already, it won't use that time. So that's the deal. Okay, so well, I guess you will have those. You can have those that PPT, that PDF from Menlo. So you can always have another look here and check how to set those times properly. And meter CT settings, as I mentioned before, also when the default setting is a CT. But if you use meter, you have to activate that meter. So deactivate CT and replace him with the meter, and then inverter will start to read from the meter because before that he's still trying to get information from CT on the pin, as you maybe remember, first, second, and third, and then sixth, seventh, and eighth. Fourth and five are reserved for the meter. And then if you turn here into meter, then it will start to read from pin 4 and 5 in the meter CT port, and then the communication will be open for inverter that is connected to the meter. Right now, so there are some additional settings. When you set meter, you have to check if there is meter is enabled, and if the meter has address 1. Of course, it always has address 1, but it's good to check. Just be sure that everything is on the place. And we have some positive and negative. That means that if by mistake installer will connect the meter backwards, right? And you see, come on, like it should be sending to the grid and not taking from the grid. So that means that it's just connected backwards, so you can easily, sitting at your home, just change this from positive to negative, and all the readings will be interpreted. The inverter will start to read them properly, because he will know that he has to negative all the readings that the meter is sending to him, all the informations. Great, and that is one of the last slides, but I think it's very important in many places. So export control through remote settings, how to set really export control, zero export control which is really as close to zero as it's possible. It will be never, of course, an ideal zero. An ideal zero you can have when you disconnect physically grid. The energy flow both ways, and the slight small delay between measuring and informing and reacting. It can always have a little bit of power to go in to the grid, but to make this little bit as is possible, so as close to zero as is possible, we strongly recommend not only set export control to zero, but also set this unbalanced phase as enable, and to set per-grid bias to inverter. The per-grid bias is just a tendency on the meter. So the inverter is, if you set to inverter ENV, that means inverter will keep the tendency of rather taking a little bit from grid than exporting a little bit to grid. So that's just a tendency, like sliding on the skis, on the carving skis. You cannot go straight. You have to just choose which edge you are using right now. So this is the tendency on the edge on the meter. Because there is no way to really keep that on perfect zero on the measuring device. So I think this is nearly it. Yeah, some installation tips. Before you do installation, always has to be some kind of a design, and please use this SolaX. SolaX created a design system, so you can design your design tool. And in that design tool, there are PV module sections and inverter and battery sections. So you can do your system design and then generate the design report. So that's very handy. Please check that page, design.solaxcloud.com. And another thing is, I already mentioned that the KB. That's a really nice place when you're looking for information about how SolaX is doing, about the certificates, about the user manuals, and about some specific instructions about solutions like heat pump, EV charger, or generator. You will find them there. Just kb.solaxpower.com and browse. Search for anything you are looking for, and most likely you will find a nice answer right over there. And I nearly lost my voice already, so I can reach the port and say thank you so much for your attention, and I hope I didn't make you sleep too much. So, but yeah, I need a little bit of water.
Sure. Thank you, Miroslav, for your training, for your time you give it to us. There was a very interesting conversation in chat. I hope we find a solution for and answer for all of your questions. If you have further questions in chat, there is email to us, support.en@menloelectric.com. Feel free to write to us. If we can answer, we will support you. If it's above our competition, we pass your question to Mirosław. Thank you for your presence. Thank you for your attention. I hope it was interesting and fruitful for all of you. At the end, I will just mention that all this video was recorded and it will be published in our YouTube channel, Menlo Electric. So don't hesitate to subscribe it. Also, each of you will get presentation, which Mirosław used, and a certificate of be a part of this training. if you share this certificate on your social media like LinkedIn, like Facebook, you will get free of charge delivery from our online shop. So I hope you will do that to get that substance. That's all from our side. Thanks again for your presence, and I guess see you soon with the next training.
Thank you so much, and see you next time.